Imagine a scenario in which you and your friend owns a notebook in which whenever you perform a transaction like sending money, receiving money, borrowing or lending money to somebody, you record it with that specific time. And someone else look at the transaction notebook and then add it to a library. Immediately it is added to a library, no one can modify or erase the data in that notebook, and everyone have access to that library to view the library, but they cannot modify it, and the transaction can be traced that somebody performed a borrowed transaction or a transfer transaction with that specific time. That's example of a blockchain. Blockchain is immutable, meaning that whenever data is written to it, the data cannot be modified or erased. It is transparent in the sense that anyone can see the transaction and see which wallet address or who performed a specific transaction. It is also decentralized, meaning that no individual or company controls it. Let me show you how it works. Okay, so this is example of a blockchain. In this case, you can see different blocks right here. So just consider this as a computer program that was coded to perform this function. So we have block A. So consider this alphabet as the block hash. So we have block A, and block B has the parent hash of A, and block C has the parent hash of B, and block D has a parent hash of C. So this hashes is like a fingerprint of that block that verifies the existence of that block. So we also have transaction in it. So if you go to this block A, you can see this block underneath the block A. This is known as a pending block, in which some blockchain makes it accessible to anyone and some blockchain makes it inaccessible to anyone unless for the validators. We are going to explain that later. So now in this specific block, a transaction, which is like the notebook that you recorded, has been seen by validators, which is someone that verifies the notebook and add it to a library. So consider this as library A, which is block A that has fingerprints A. And then with this transaction that is in your notebook, for example, you being Fabio sent 20 USDT to Jack. That is the recorded transaction that you recorded. And then Ima borrowed 50 USDT from this specific vault. And then Sam deploy this specific contract. That is what is recorded on the notebook. A validator, which is people that run computer known as node, sees the transaction that you perform and then takes it and add it to a block. So all the transaction has been added to a block, and then once it is completed, a block hash will be generated for that block, which is the fingerprint of that block. And after that, it would has a timestamp, which is the specific time that the block was validated. So when the block is completed for a specific times, different blockchain has different confirmation time, or a time in which the block will be added, a new block will be formed. So the transaction will be added to the block and then chain it with the coming block. So this is going to be the coming block that comes after this block. So it will have the fingerprints of the previous block, which is block A, and then its own fingerprints, which is hash B. So we then have the two fingerprint to know that it is chained together. This is just a computer program that was coded to perform this function. So we then have the second block with the transaction, the third block with the transaction. So whenever you send money to somebody using cryptocurrency, for example, you send USDT to somebody to another wallet, the transaction, whenever you perform send on your non-custodial wallet, automatically goes into a pending block, in which some modern blockchain makes it inaccessible to the public, but only for those validators who add it to a block and chain it. So your transaction goes here, and then from here the validators see it and add it to a block. I am going to show you a live example of it right in this section. So let's navigate to a blockchain, Ethereum layer 2 blockchain right away, which is the base blockchain. We are going to go to their explorer, which is basecamp.org. So you can navigate it on your mobile phone to basecamp.org. Once you get to basecamp.org, just click on this section that you see blockchain on your mobile phone or on your computer and then click on transactions, you are going to see a lot of blocks. You can see this is the block number that is just added right away with this transaction. So if you go to blockchain again and then go to few blocks, you can see the list of blocks. So this is a block with a block number, block with a block number, just the way we have this block, block and block. So let's navigate back here and then click on this block that was added 5 seconds ago. So if I click on it, you're going to see that there are 187 transactions and 800 smart contract call or contract interaction. So we are going to explain that later in this course. And then you can see the block height, the timestamp in which the block was added, and then you can click on this transaction to view the transaction. And then if you navigate back and then click to show more, you are going to see the block hash, which is the fingerprints of the block, and the parent hash, just the same way we have our block hash A, block hash B, and the parent hash. So this represents these fingerprints of this block that you are seeing right here, and this represent the parent hash of the previous block. So if you go to transaction, just the way we have our transaction here that is recorded here, and you go here, you will see a transaction hash, the method of the function that was called from the smart contract, the block number, the from to, just the way somebody sent funds from this wallet to this wallet. So you can see, for example, this is a transfer transaction in which if you click on it to open the transaction, you will see that there was a record of a transaction here that somebody actually sent 104 USDT worth of ETH from this address to this address. So this is transparent. Anyone can see the transaction that is occurring in this blockchain right away. Whenever somebody perform a transaction like this, there are those who validate that transaction, and they are known as validators. And those validators actually perform checks using their computers, in which we call node. And then their computer is going to check this transaction from a pending poll, which is this poll I showed you right here, and then add it to a block. And then once it is added to a block and the transaction completed, like this one has 99 transactions right here, the block then verify and then chain it to the previous block. But these validators are rewarded with the coin of the blockchain. For example, base chain is Ethereum layer 2. So for people who are running validator nodes on the base chain blockchain, they are going to be rewarded with ETH, which is base ETH layer 2. We are going to explain more on that later on. You might ask yourself, since blockchain is decentralized, then how come is it performing that somebody will have to run a node, and then is that not centralization? Then this is how it works. Anyone can decide to run a node and validate transaction, including me and you, if you have the requirements. There are certain amounts of the coin of the blockchain that you need to own to run a node. For example, I have a Raspberry Pi 4 right here, as you can see. So this is a microcomputer, just for demonstration. If this was a computer that is capable to run blockchain node to validate transaction, all what I have to do is to install the software right here, connect it to internet, put the amount of coins, which is in this case of base blockchain ETH, and then leave my computer to run 24/7. And whenever my computer sees that transaction is being sent, it is going to compete with other blockchain nodes that are being running in different parts of the world to verify the transaction. So that's how it works. That is why it is decentralized. Anyone can decide to join the network and then verify transaction. It must not be a single company or single individual.